Lesson 13.1 is using trigonometry with right triangles. But first, let's review a basic concept from geometry class, the Pythagorean theorem, which states that a squared plus b squared equals c squared. And c squared is the hypotenuse on a right triangle. So here I have a 90-degree angle indicated. The side opposite the 90-degree angle indicates the hypotenuse. It's the longest side. So knowing that, and again, this should be review, the 3 and the 4 represent the legs. So 3 squared plus 4 squared will equal x squared, or from the formula I have c squared. So we end up with 9 plus 16 equals x squared. 25 equals x squared. And then when we take the square root of both sides, we find out that x is equal to 5. We only want to include the positive answer because this is distance or a measurement, a length. So we're not going to worry about the negative answer. Example number 2, we go across from the right angle. So 7 is the hypotenuse. So the 7 goes on the side all by itself. So it's going to be x squared plus 6 squared equals 7 squared. X plus 36 equals 49. We're going to subtract 36 from both sides. So we get x squared equals 13. And then when we take the square root, 13 is not a perfect square, so we're just going to leave it as x equals the square root of 13. And so in this case, we solved for a leg, whereas in the first instance, we solved for the hypotenuse. All right. So now we're going to look at the top of the screen, and I took this from your textbook. Here we have sine, cosine, and tangent going across. Then we have the reciprocal of each one of these, cosecant, secant, and cotangent. So let's just look at the tangent and the cotangent. Notice that it says opposite over adjacent, where cotangent says adjacent over opposite. So if we're able to determine the tangent, all we need to do is find the reciprocal, and we can determine the cotangent. Same thing with our cosine and secant, and our sine and cosecant. And the final thing you might be asking yourself, what is this? This is a Greek letter, and we call it theta, and it typically represents one of the angles that are acute, not the 90-degree angle. All right, so here we're going to look at our special right triangles. Again, you should be familiar with these from geometry class. Down at the bottom of the page, I took an example from your textbook, and they have the side lengths labeled as 1, 2, square root 3. We also might label the hypotenuse 1. If the hypotenuse is 1, then the smaller side is going to be 1/2, and the side opposite 60 degrees is going to be square root 3 over 2. And for our 45, 45, 90, if we said the hypotenuse was 1, then we'd have square root 2 over 2, and then because their angles are the same, these two side lengths are actually going to be the same. So we're going to just look at the first row, the 30 degrees, and kind of take a look at where these numbers came from, and then you could complete or practice the 45 degree and 60 degrees if you would like on your own time. Sorry, one more thing before we actually look at the chart. I want to go over why you might consider using this example up here where the hypotenuse is equal to 1. So for instance, what if we had a 30, 60, 90 and the hypotenuse was equal to 4? Well, if we know that this side is 1/2 of the hypotenuse, then it makes sense that it would be equal to 2. Half of 4 is 2. Then we know that this side is square root 3 over 2, and we're going to multiply it by 4. So we know that this side would actually be equal to 2 square root 3. So by using the hypotenuse and labeling it as 1, it kind of makes it easy to solve for the missing sides. All right, now back to the chart. All right, from geometry, we know sine, cosine, tangent. Oscar had a handful of apples. Some of you remember it as SOHCAHTOA. So let's look at sine 30 degrees. So we're coming out off of the 30-degree angle. Sine says it's opposite, so we go to the opposite side of the 30 degrees, and hypotenuse, which is 2. So that's where the 1/2 comes from. Now look at cosine. So cosine, that tells us from the 30 degrees, because we're looking at 30 degrees, we want the side that is adjacent. And the side that is adjacent, there's two sides that are adjacent to the 30 degrees, but the hypotenuse is special. So we're not going to consider the hypotenuse as the adjacent side. So we have square root 3 in the numerator, and then it tells us to look at the hypotenuse, which is 2, and that went to the denominator. Now we're going to take a look at tangent 30 degrees. So tangent 30 degrees, coming off of 30 degrees, tangent says that it's opposite. So side opposite is 1 over adjacent, which is square root 3. But if you remember, we need to rationalize the denominator. We don't want to have a radical in the denominator, so we have to multiply the numerator and the denominator by square root 3. So that gives us square root 3 over square root 9, and the square root of 9 is 3. And that's where this value comes from. All right, now we're going to look at cosecant, secant, and cotangent. And if you remember from the first slide, I said that these were actually reciprocals of sine, cosine, and tangent. So cosecant, we go over to sine. The reciprocal of 1/2 is 2. Then now for secant, we're going to go to cosine, and we have square root 3 over 2. We need to write the reciprocal, so it's 2 over square root 3. But remember, we cannot have a radical in the denominator, so I'm going to multiply the numerator and denominator by square root 3. So I get 2 square root 3 over square root 9. The square root of 9 is 3. So that's where this one comes from. And then I'm going to make a little bit of space and we'll look at the last one. Now we want the reciprocal of tangent for cotangent. So we have square root 3 over 3, and we're going to write the reciprocal. So 3 over square root 3. Again, we need to rationalize the denominator. So we're going to multiply by square root 3, square root 3. So 3 square root 3 over square root of 9, which is 3. And then we should be able to see that our 3's can cancel. And that's where the square root 3 comes from. And we could do this for 45 degrees and 60 degrees, but we're going to move on to something else. All right, you might be asked to evaluate the 6 trigonometric functions of an angle, and here we have angle theta. So because we don't know what the hypotenuse is, I had to use my Pythagorean theorem to start off. So my legs went on the left-hand side and my c squared went on the right. And I found out that c is equal to 25. Now we're going to do sine. So here I have my SOHCAHTOA, or my Oscar had a handful of apples. So we're coming off of theta, and it says we want side opposite over hypotenuse. So the side opposite is 7, and the hypotenuse is 25. For cosine, we need a side adjacent, and we need the hypotenuse. So the side adjacent is 24, and the hypotenuse is still 25. And then tangent tells me we need opposite over adjacent. So the side opposite we determined was 7, and the side adjacent was 24. Now remember, looking up here again at the top, we have reciprocals. So to do the cosecant, secant, and cotangent, we just need to write the reciprocals. All right, so I wrote in the values. Now we have just one more slide, and make sure you have your calculator out and that the mode is set to degree. All right, so this example is a 45, 45, 90, so we could do it two different ways, but let's do it using cosine 45 first. And I know that because I'm coming off of angle 45 degrees. I was given the hypotenuse, so that means I'm either going to use sine or cosine, and then I'm given the side adjacent, so that determines, yes, it's going to be cosine. So we're going to have cosine 45 equals x over 6. I'm going to multiply both sides by 6. So 6 times cosine 45 will be equal to x. So you're going to go to your calculator, type in cosine 45 times 6. All right, so remember on your calculator that your mode had to be set to degree to get this answer. There's an alternate way we could do this. If you remember from the trig chart, if we went 45 degrees and we went under the cosine theta, we know that cosine 45 is actually equal to the square root of 2 over 2, and then we have our x over 6. We can use cross products, so we'll do 6 square root 2 equals 2x, divide both sides by 2, so this simplifies to 3 square root 2. So we could have this as an answer. Now in the last example, you're asked to solve for side C and side A. I chose to solve for side C first. So we're coming off of angle 28 degrees. I know I'm going to be using C because that's what I said I wanted to solve, and I have to have a number value, so 15. So I go up to my sine, cosine, tangent ratios, and it says I'm using adjacent over hypotenuse. So side adjacent was 15, hypotenuse is C. So we're going to multiply this time, whatever the denominator is. In this example here, we multiplied by 6 because that was what the denominator was. So here the denominator is C, so I'm going to multiply both sides by C. So we end up with cosine 28C equals 15. We have to isolate C, so we're dividing both sides by cosine 28. Cosine 28. Pause the video, put 15 divided by cosine 28 into your calculator and see what you get. So you should have got C is approximately equal to 16.989. Now we're trying to find A. So we have opposite and adjacent. So opposite and adjacent meant that I had to use tangent. So tangent 28. The ratio was A over 15. We multiplied both sides by 15. Pause and see what you get. You should have got A is approximately equal to 7.976.